presentation that we're going to have now by Dr. Abdul Rahim of ClassNK is the perfect introduction to that panel, because he's going to share with us the cutting-edge technologies exactly for new ships and for shipping today. So it is a great pleasure to welcome him to the podium to give us his presentation.
Good afternoon, ladies and gentlemen. First of all, I have to thank the organizers for giving me this opportunity to talk about designing ships of the future. As you know, the whole day we were hearing about decarbonization, zero emission, and things like that. The whole industry, not only ours, the entire world, all the industries are talking about decarbonization, and we are also doing our bit. But for the shipping industry to be decarbonized, we need to have ships which has no emission. That means you have to design future ships. And that is what exactly I'm going to talk to you today, designing ships of the future and cutting edge technologies. So I'll be initially introducing ClassNK. I don't know how many of you may know or may not know. I will talk about ClassNK in one slide, then I will go into GHG emissions from international shipping, then Japan's effort, what Japan is doing to address this, then challenges to achieving zero emissions, and what we need to do. So this is about ClassNK. We are established in 1899, about 120 years ago. We have 130 offices around the world, and we are authorized by about 100 countries to do survey and certification on their behalf. And in terms of tonnage, we have 268 million gross tonnage, and we have about 20% of the world fleet. And on the right side, you can see the number of ships, and now we are leading a lot of class societies in terms of the number of ships. Now coming to the global CO2 emission, the total is about 33.5 billion tons. Out of which the main countries are China with 28% and the US with about 15%. And the European Union is about 25 odd countries. It's quite reasonable, about 9.4%, of which Germany has 2.1%, which is exactly the same as the international shipping emission. That is, our shipping our emission is equivalent to that of one country, that is Germany. Now, how to reduce that? You know, the United Nations Framework Convention on Climate Change has come out with the Paris Agreement in 2015 to limit global warming to well below 2 degrees or to 1.5 degrees. So each country has their own GHG reduction targets, including domestic shipping is allocated to that country, whereas for international shipping, one particular country cannot be held accountable. So the whole thing was given to IMO, the International Maritime Organization, and IMO is doing their bit. Even right from 2013, they have a regulatory framework to reduce the greenhouse gas emissions. And in 2018, they have set a target to reduce CO2 emission by, the greenhouse gas emission by 50% by 2050 compared to 2018. But this is getting revised because the world over is now inching towards zero emission by 2050, which is a quite ambitious target. So the governments all over, especially Japan also, is promoting R&D to get zero emission technologies, and the European Union, in the morning it was talked about Fit for 52 to introduce carbon accounting, say the emission trading scheme, or to promote the use of greener fuels, that is the Fuel EU Maritime and such initiatives. At IMO is aiming to revise the target that I just mentioned, and also they are putting up some regulatory framework to accelerate net zero achievement. And in the private sector, the automotive sector, energy, mining, finance, even Amazon or IKEA, all are gearing up for net zero by 2050. So that means everybody has to come together, to pull together to achieve this target. Now let me go into Japan's Japan's efforts. The Japanese government has announced in 2020 that they are going to be net zero by 2050. So the Japanese shipping industry, also the Japanese Ship Owners Association, they have also set the target of net zero by 2050. They announced it last year. And private companies, so for example, the major shipping companies like NYK, MOL, and K-Line, they all announced they are going to be net zero by 2050. They announced it last year. So we have a lot of work going on in Japan to achieve this. So to achieve this, one of the main target is zero carbon or alternative fuels, which can lead us to zero emission. And as you know, LNG is now mainly used as a transition fuel. And the biomethane, we are expecting to be in the market by 2025, followed by carbon recycled methane, which are much more environment friendly. And simultaneously, we are talking about hydrogen and ammonia. They might come into the market by 2028. And in addition to these fuels, other technologies like onboard carbon capturing, which was discussed earlier, and then wind-assisted propulsion systems and battery propulsion system, all these are in the research stage, and come 2030, we might be having quite a good number of alternatives. Now this is the roadmap that was brought out by the Japanese government. The R&D, they are enhancing R&D capabilities, especially on the engine side, single and dual fuel engine, for example, hydrogen fueled engine or ammonia fueled engine, and carbon capture. They are trying on that. Then we have quite a number of pilot projects ongoing that I will come to you in the next slides. Then the government is promoting some incentive scheme that is to provide energy efficiency requirement and market mechanisms and some kind of emission linked financing. And simultaneously, we are developing the safety requirements and training and competency of seafarers and methodology to evaluate energy efficiency. So we are expecting maybe by the end of this decade, the first generation zero emission ships will be plying the seas. And one of the biggest challenges will be the establishment of fuel supply, because you need to have bunkering facilities when a large number of ships are coming out with alternative fuels. That is also we are tackling. And we are expecting by 2050, we will be having ships of this kind. That is hydrogen fuel ships, low speed LNG, wind propulsion ship, ammonia fuel ships, or CO2 ships that can capture CO2. So these are, we are envisaging, these kind of ships will be coming out by 2050. Now, let me talk about what ClassNK is doing in this. So recently we have come out with safety guidelines for the use of alternative fuels. And first I will talk about ammonia. Quite a number of projects are ongoing. One is the ammonia-fueled ammonia gas carrier, where the cargo can be used as a fuel. Then ammonia floating storage and regasification barge. Then ammonia-fueled tugboat, and ammonia bunkering vessel. So we have given approval in principle for all these vessels, and the development is ongoing. And a couple of more ammonia-fueled, this is a car carrier, and this is the ammonia-fueled very large gas carrier, and ammonia-ready LNG-fueled Panamax bulk carrier. So for all these, again, approval in principle was issued, and it is in the developing stage. Now coming to hydrogen. This is the liquefied hydrogen carrier which was delivered last year, end of last year, and it is already shuttling between Australia and Japan, bringing liquefied hydrogen from Australia to Japan. And another large-scale liquefied hydrogen carrier of 160,000 cubic meter with 4 tanks of 40,000 each is in the drawing board. It will be completed maybe within 2 years. That is what Kawasaki Heavy Industry says. Another one is high-power fuel cell vessel. The basic design is already completed, which uses hydrogen fuel cells. Now coming to battery propulsion, this is the 100% battery-operated tanker owned by Asahi Tanker. This is already delivered. Then we have the electric tugboat powered by battery and hydrogen fuel cell, and power transfer vessel. This, what we mean is, the offshore power, wind power, is generated in the offshore wind farm. It is stored in the batteries, and then these batteries are taken onshore for use in the port and other onshore facilities. Now, wind-assisted propulsion system. One is used the rigid sail. I will come to this in the next slide. Then we have the automatic kite system, which is used by K-Line, and they are planning to put it in quite a number of vessels. And of course, rigid sail and solar panels, and all approval in principle were issued for these kind of vessels. Then onboard carbon capture, and this is a vessel, K-Line vessel, where we have installed the test kits to capture carbon from the exhaust. So we were successful in doing that. And this is a part of the CC Ocean. This is another project in Japan ongoing, in which the captured carbon is pumped into the seabed. So that project is also ongoing. And we are developing a big liquefied CO2 carriers so that the captured carbon can be transported and it can be pumped into seabed, either directly or through some other mooring facilities. And of course, out of the captured carbon, about 15–20% can be used or reused. For example, if it's a pure CO2, it can be used in the food industry or some other industry. And then this is the LPG reformed gas-fueled coastal LPG carrier. So one of the initiatives that we have is we will initially develop it for smaller vessels, then scale up and use in larger vessels. And also another project ongoing is methane slip reduction, especially when using ammonia. So approval in principle were issued for all this. Now coming to the hard sail, I was talking about the Wind Challenger project. This is the actual sail when it is enlarged, and you can actually bring it down for easiness of cargo operation when the bulk carrier is at port. And the first vessel with this will be delivered actually October 8th, that is in 2 weeks' time in Japan. And yet another vessel is getting ready. This is a wood chip carrier for Enviva with, it's a combination of hard sail as well as rotor sail, and it will be delivered in 2024. Now, we are talking about all this. We need to develop a lot of technologies. So our intention is to promote investment to develop alternative fuel vessels, alternative fuel supply chains. And we need the participation of all involved, ship owners, shipbuilders, suppliers, financiers, everyone to chip in. And we expect, if you want to be carbon neutral by 2050, trillions of US dollars have to be pumped in for development. But the problem is we don't have any clear pathway. Which one is going, either methane or hydrogen or whatever it is. And the industry is not much willing to pump in money, because you never know, after spending millions, day after tomorrow, the technology is outdated and it cannot be used. So that is why we need policy measures by the government to encourage investment. So in the morning we have discussed quite a number of issues like market-based measures, carbon tax, emission trading. Then the government has to come out with regulations to further energy efficiency and fuel type standard. I mean, George in the last session was talking about the standard of fuel. So that means we need policy government measures from the government to support first movers to accelerate the transition. So that means it has to be a collaborative interaction between the governments and the industry to achieve what we are talking, that is zero emission by 2050. Now, let me talk to you about how ClassNK is doing it in achieving this goal. First, we are giving total green assurance, like GHG emission verification, and also third-party opinion for ESG loan bond, because these days quite a number of financial companies are linking their loan to the energy efficiency of the ship. So we as third party are verifying the energy efficiency so that if it is below a certain level, they get a priority interest to their loans. And another thing is technical support. As I mentioned before, we are giving approval in principle of technologies that is being developed so that the developers have the confidence to go ahead. Then another software is ClassNK Zeta. It is available in our website. It's a GHG management tool where say, each ship's carbon intensity indicator or EXA can be readily calculated, and for the whole fleet it can be done, and you can simulate it. Say for example, you are changing the bulbous bore of a vessel so that it improves the energy efficiency maybe by say whatever percentage it is, that you can input in the system and simulate and get a CAA value, and of course you can develop the report and straight away give it to the authorities to approve. Today more than 3,000 ships are using this ClassNK Zeta. Then another thing is we are giving support to GHG management of various companies, and say for example developing EEXI, CAA, and SEMP Part 3 and all those regulatory requirements. So that means we need not only the governments, but also all the stakeholders, class societies, shippers, shipbuilders, engine manufacturers, suppliers, owners, financiers, everybody to come together. That's the only way forward, cooperation. And each individual element cannot attain our common targets. We need all the parties to come together and promote this. In this case, this is my last slide. I would like to introduce about Green Innovation Fund. This is one example of how the governments can play a role in it. In Japan, they have created a new organization called the New Energy and Industrial Technology Development Organization called NEDO to realize carbon neutrality by 2050, not only for shipping, for the entire country. And the total outlay is about 16 billion euros, and duration is for 10 years from 2021. This is over and above what is already being invested in developing the hydrogen economy and others. And maritime industry is also getting its share. It's about 32 billion Japanese yen, that's about 250 million euro. And as part of this, we have initiated quite a number of projects to develop next generation vessels that use hydrogen, ammonia, and LNG, and other low emission fuels. So first one is the hydrogen fueled engine, fuel tanks and fuel supply systems is being developed as part of this project. Then ammonia fueled engine and related supply chain. Then methane slip, how to reduce the methane slip by at least 60%. That is yet another project. And also we are developing next generation ships I have mentioned before. With this, I would like to conclude my presentation. Thank you very much.